Carlton, welcome back to Talk Python to me. Amazing to have you here.
Thank you, Michael. Thank you for having me on again.
Always fun to talk with you. Fun to have you back. We're going to talk about one of my favorite topics, async, both for the reasons it's amazing and the reasons it's like, why? Why is it this way?
Why do we do this to ourselves is the thing, right?
Exactly.
Yeah, carry on.
Wait, I want async. Oh, but I didn't want it like that. No, just kidding. And specifically with regard to Django, you did some really interesting updates with Django that we're going to talk about. But first, your teams, they're still in the World Cup. How are we doing?
Oh, yeah. Well, so I'm British by birth, so English by birth. So I was supposed to support England, but I live in Spain. So depending on who's winning, who's doing better, I get to flip my allegiance.
I think that's really amazing because you if one of your team's not doing well, you can just I'm gonna just cheer for the other one. It's great. You get like two shots at the thing.
Yeah, I mean, in the last European Championships, we had the England-Spain final, so I couldn't lose, really.
Yeah, that's amazing. Yeah, so the U.S. team advanced yesterday as well. They played really well, so I'm very, very excited for that.
Yeah, it's lovely to see emerging nations do well in the World Cup.
A long time ago, that would have been like some kind of joke. People are like, surely you're joking. Surely you're joking about this. But honestly, soccer or football, not American football, is popular in America. So super cool. Good. Yeah. Glad to hear it. And you're back. So tell people just what have you been up to? Not everyone listens to every episode. So a quick introduction for yourself, maybe.
Okay, so my name's Carlton. I've long time worked with Django. I used a former Django Fellow, did that for 5 years. I'm on the Django Steering Council. I was on the security team for 8 years. I maintain a whole load of packages in the ecosystem. So, I'm quite vested there. And yes, I use Django and have done for, I don't know, however many years to build web applications for, to pay the bills. Had a busy spring. I was everywhere I went to. There was a PyTV event organized by JetBrains in Amsterdam in March that I went to. That was all on YouTube. It was, I don't know, 11 hours of live streaming or something. It was amazing. Then I was in DjangoCon Europe in Athens in I think April, and then in May I was at PyCon Italia which was in Bologna. PyCon Italia really is a lovely conference. You should make your way there. And now I'm just home and I'm exhausted. I had a quick holiday with the family, but now I'm hiding at home until September, where we've got Django on the Med, which is a 3-day sprint event, which is going to be in Pescara, Italy, which we're looking forward to.
That sounds really, really nice. I love traveling, but the jet lag kind of blows me out eventually. I'm like, this is like 11 hours jet lag. I don't really want to do this anymore. But It sounds to me like you're kind of able to keep it in the broader Euro neighborhood, which is nice.
Yes, I was, which it does help because there isn't that massive time change, but it's still hard work, right? Even though you have fun at these events, even though you're seeing your friends, even though it's, doing what you're vested in, they're long days and you have to be full on, in action all day, each day. And so by the time you get home, you are kind of exhausted, and then obviously you've been away and you get home, you need to be present for your family too. So there's a limit to how many of these I can do. So I won't do any other events this year because
that's good. That's good.
Too much.
Yeah, I remember traveling when we had little kids, and that was a whole nother level because you'd come back. And it's like you've been gone for a week, so I need some help. And you can take, but I'm exhausted. You understand? But at the same time, it's a fair request,
Yeah, no, absolutely. I mean, our kids are older now. The eldest is 18, will be 18 next week, just about to go off to university, and then 16 and 13, 14. So they are a lot easier than they used to be, but still, it's a big ask on my partner to go away and they're alone for the whole week. But
absolutely
in that point position, we might call it.
Yes, exactly. So tell people, you mentioned Django on the Med.
Yes,
I talked to Paolo about this a couple episodes ago, but tell people you're going to be part of this too, yeah?
Yeah. So this was Paolo's idea several years ago to have core developer sprints for Django. Because at the end of DjangoCon Europe or the end of DjangoCon, we always have a couple of days of sprints, and they're some of the best parts of the conference. But also, it's around the time when people are leaving, and your people are all already kind of exhausted, having the 3 days of talks plus then of the sprints. So it's like we wanted more, and we decided to do this event, and we were like, yeah, this is a good idea. And it didn't happen. And then I think Dublin, a year and a half ago now, we were like, no, come on, let's make it. So we said we're going to have it in Palafrugell, which is my hometown. We did that last September, or last October, sorry, beginning of October, and we're doing it in Paolo's hometown, Pescara, this September. And it's, as I say, it's 3 days to get together and work on Django. And we had some really big features landed. Like, for instance, Django 6.1 is in pre-release now, and it's adding an ability to have DB level cascade options for the on delete. So on delete is, well, you've got a foreign key, so I've got a user, and that user has a bookmark. Well, what happens when I delete the user? What happens to the bookmark, right? It's got a parent relationship. And so normally you would cascade that. Now, Django's always offered this option, but historically, it's done that in memory, in Python. It's walked the tree, and it's got the objects, and then it's deleted the leaves, and then the stems, and only finally down to the branches. And now that can be very costly at scale. And
I'm going to delete this one record that references several tables with 1 million entries. Like, that could be a lot of memory.
Exactly. You've got like an organization that's got team members and projects, and you delete the organization, and it just brings down your application. Basically, you get out of memory issues. So the database still has to do that work, but the database is much, much, much better at doing that work than Python is. And so anyway, we've got this new option. This ticket had been open for, I don't know, so many years, because it was really hard. And we had Mariusz Feliciak, who's a former Django Fellow and one of the core ORM contributors, Simon Charette, who's one of the core open source contributors, Lily Foote, Jacob Tyler Wells, who's the new Django Fellow. We had the 4 of them just there working together, and they were able to get this over the line. And it's literally something which would never have happened except for the time that was available at Django on the Met. So we've got exciting plans for this time. We're hoping to get people from around the community to come. And I know, I'm really excited about it. The first one was a proof of concept. It went really well. The second one's lining up to be amazing too. And once we've done 2, well, it's kind of established. And we're in
then it's a tradition. You got to do it.
Yeah, exactly.
You got to go hang out in the Mediterranean. So I've done a lot of remote work in my life, and I find, when we do in-person meetups, get the people who are all distributed together, it just changes the energy,
There's something about the bandwidth of face-to-face communication which just isn't replicable, which you can't replicate.
Replicable.
Online. Yeah, thank you, Mike. Thank you, Mike.
Gotcha. I got you.
But yeah, it's I don't know. I mean, look, it works online, but as well, there was a good session as well. So with Django, we've got this, we've had recently this new features board, which was an attempt to take people suggesting features away from Django's track instance, which is kind of old and scary, and is a place for the work to be done, and put it into a GitHub project, where we could have a project board, and we could have upvotes, and we could have a Kanban board to see what were being advanced, to try and give a bit more visibility into the process. And sometimes there's disagreements, and those disagreements online, they can go on forever and ever. But we were able to have a session, and there were different voices from different opinions, and we were able to come to agreements in 5 minutes on topics which had been rolling on the boards for months. And that kind of, look, I can see why you're saying this. It's really hard to get that online. As many emojis as we use, and as much as we try and communicate openly, it's
as much slack as you want to throw out there. And since 2020, it's kind of been just, obviously remote is better and so on. And there are mega advantages, don't get me wrong, but it's not always better in lots of ways. So
yeah.
So I guess for this, go ahead.
Go on. You mentioned 2020 and it's COVID. It's one thing that I was Django Fellow over that period, and it was a really hard time for Django, because I think that the pandemic really knocked the back out of the community. We had older people stepping away, we had young roots that were starting to come, and then the pandemic came, and it was kind of like this really, really, really tough period. And it's now 5-6 years later that we're looking at it, and we're thinking, actually now the activity that's going on with things like Django North Space, and the new members that are coming through, and the people who are active in the community think, well, next year when the steering council is re-elected, there's obvious candidates who weren't there, 2 years ago. And it's taken us, I think, half a decade to recover from the real knock that was COVID.
Wow. I believe it. So is this for just for core devs, or is this open to people who just want to contribute?
No, it's open to everybody. Obviously, if you're an established contributor, it's going to be easier to get going. But it's also about bringing on new contributors and teaming people up. And if you come and you've got a particular interest in Django, if you're a total Django novice, it would be strange to come to choose Django on the Med as your first event. But if you're into Django and you know it and you want to get contributing, that's part of the plan too, is that we have both experienced and new contributors, and we can team people up and get people working together. And just, what part of the contributing to Django problem is the learning curve. So it feels like it's a big scary thing. Whereas if you sit down with somebody in a room and you work on what they're working on, you're like, actually, I could work on this side ticket, and all of a sudden people are off.
Well, it suffers from what many of the successful projects out there do. It's super polished. It's used by millions and millions of projects. It's hard to just look at it and go, oh, I'll just change this without regard to all that knock-on effect, right?
Yes, and that's where we the new feature part of the new features repo was about giving a space where people could put their ideas forward without having them immediately closed as won't fix. Because if you went and oh, can we integrate React as no, we're not going to do that. You can use React, and here's how we use React, but we're not going to integrate it into Django, say, as an example. And that would be open. There'd be no close won't fix, and people felt that was a little bit too.
A little too Stack Overflowy.
Well, yeah, it wasn't ideal. So the new features repos is to allow space to develop for a conversation, and then those ideas which have a bit of traction, we can say, no, do you know what? A lot of people have said they support this one, or we can advance it. Yeah.
Sounds good. So you have another project coming along, the Mantle. Tell us what this is.
Django Mantle. It's my take on a modern serialization story for Django. So the big topic we've had is about REST framework, and REST framework is aging, and REST framework is wonderful, right? And it has been wonderful, but the serializers in particular, they're kind of last generation, and there are much more modern approaches available now, involved in Pydantic, in message spec, in attrs and cattrs, which is what I use, that are much faster than they used to be. They generate code which is almost as quick as you would see if you hand wrote it. If you wrote the code to literally pull this attribute, this attribute, this attribute, the code that's generated for you by, say, cattrs is as quick as that code, which is amazing. Whereas REST framework serializers, they go through and get the field object from the model, they get the value from it, and it's like, hang on, all of those loopings are very slow by comparison. Okay, so then the question is, well, why don't we just use Pydantic? Well, Pydantic's fantastic, but it's not ORM aware. It doesn't have any insight into how Django works or anything. So Django Mantle is my take on that. It's the Slag. It's your type safe wrapper around Django's liquid core. So you write these attrs classes, and then you just instantiate a query object, and you go fetch. And it fully instantiates your object to the shape you define, and it fetches all the data all in one go, and it can do that for nested objects, and you can do writes with validation and all these things. And it's ORM aware in that it only selects the fields that it needs, and it does the prefetch relateds for you, so that you don't get this n+1 query problem, right? And it's very good for performant fetches of just the exact data you want. You end up with your objects being fully Python typed. They're attrs classes, so they're typed. Your type checker knows the way around them. MyPy or Pyrefly is now adding support for attrs classes too, I see this week.
Cool.
So anyway, it's an attempt to show what a serialization story using these modern approaches can look like. And then from there, it's like, well, okay, what does an API framework in 2026?
I love it. I love this idea. I think there's a lot of value in taking some of these very focused, lightweight, dedicated, like data structures, right? Like C-adders or pydantic or just straight data classes,
Yeah.
and somehow integrating them in here without just this heavyweight stuff. Like you talked about the eager loading, and some of the other things, like the typing can be weird as well. Like SQL Alchemy, you kind of have to lie to it
Yes.
somehow. Do you either lie about it being a database thing, or do you lie about it being a an integer when it actually gets the value, right? Like,
Yeah. So because the actual type is what a Django deferred field, right? For a Django modifier, it's a deferred
exactly.
field. Well, what on earth is a deferred field? Where it's an object that has the descriptor protocol, so when you access it gives you the converted value from it. I don't want to type that.
Exactly. Well, and even if you do, then you try to add it to an integer. It's like, you can't add that to an integer. That's not the same thing. You're like, but it's going to be.
Yeah. It's going to be. So this was the topic of my talk that I gave in Amsterdam and DjangoCon Europe and the PyCon Italia. I did slightly different versions because I had more time at DjangoCon Europe. So I went more into the way we grow from, say, an active record pattern, which is like a Django model, right? It's an active record. It's your database row. It's your database row, but it's also an object that's got logical behaviors, to a more separated approach where you're like, hang on, I don't want my display logic and my aggregation logic and my user validation logic all living on this one database class. So how do we separate those off? That's kind of where Mantle came from originally. But the idea was that, and my take is that Django's ORM is built on these very powerful dynamic patterns that Python allows. And retrofitting static typing onto that is going to be a real problem. So instead of that, that's also a dynamic C. On top of that, we have these static islands where we can have all the nice type safety features of modern Python, but we're not trying to eliminate the very powerful dynamic features that we have underneath. And so the mantles, the shape classes that you define, they're your static islands, and there you can add all your domain logic that you want to, and you can have it fully separated from the database. And they are just pure Python classes. There's no data mutability in there. There's no like say, oh, actually I modified a property and saved, and now I've updated something. No, there's none of that active record stuff going on. So it's a kind of way of getting some of the benefits of these this sort of separation layers type approach, whilst still keeping everything you love from the ORM.
Spoken like someone who appreciates some nice architecture and layers. Very cool.
Well, the issue is, as your application grows, the complexity grows with it, and you need more structure to manage that complexity. Like, you simply do. Like, the issue isn't that you started with a Django model. It's that your Django model grew and then grew and it grew, and all of a sudden it's got methods on it which are several distinct responsibilities. And then you think, oh, I'm getting a lot of code here. So you start doing dry, you start abstracting methods, but that abstracted method wasn't for a single responsibility, so it's not clean. So that you've got and everybody who's grown a Django app has seen this, and it's perfectly natural and it's perfectly normal. It's just how applications grow. And Mantle is kind of my take on, well, how do we deal with that? How do we grow from the active record pattern that we began to something that's more robust? And it's not that you should start with the more robust patterns, because you're over engineering at that point. There's a nice road we have to walk between these two problems. And that's the joy of crafting the application over time, right? That's why we're programmed.
I love it. All right, let's chat. I'm losing my place. Let's talk about Django 6.1.
Yes.
I think it's coming out. It's not quite finished, but there's a lot of features we're going to talk about that are pretty exciting and related here, right? A lot of new things coming out of the database, for example.
Yeah, so I think it's in beta now. So it's going to be a release candidate in a couple of weeks, and then we're about a month away from the final release. Oh, by the way, I see you've got the page up there. The Django Developer Survey is on right now. Do take it, folks. We want as many replies as we can. It really does help drive forward the development of Django. So do give that five minutes there of your time to answer the questions. But what's exciting? We already talked about database level cascades, right? That's my big feature, because that's something that you just couldn't work around, and there's no in Python solution to that. We wanted that. You'd have to, well, I have created a custom database backend and changed the way it creates. No, that's not a sustainable way. So database level cascades are my favorite one. The one that I think more people are excited about is called fetch modes, which are on query sets. So we talked about the prefetch related with the way Mantle handles it, but the idea is you've got an author, and so you fetch a user, and they've got a list of bookmarks, and so you get the author, you get the user, and then you iterate for bookmarking users.bookmark, display the bookmark. And so what happens is it goes through, and you get this n+1 query where it goes and fetches the lazy related object, and that's great at small scales and when you're getting going, but it's a performance, nightmare basically, and this n+1 problem that comes up is something that people hear all and all again. So fetch modes let you say, look, fetch peers, which is the exciting one. It lets you say, if I access the first element in a list of related objects, go and get them all at once. And so it's like a deferred prefetch related, and that's going to be a lot easier to manage in a lot of cases than having to manually add the prefetch relateds in each case, because those often become difficult to do by hand. They're all right to add the first time, but they become difficult to keep updated. And then you're suddenly prefetch relating something which you're no longer using, and so fetch modes.
Yeah, your data access layer, maybe you're right, says get me all the books, but then you might have to add like some kind of flag that says and the authors, because sometimes you want to call that function and you want the authors, but sometimes you just want to just list the books, and you don't need that. And it's like, yeah. So this way it kind of just lets you says, if you're ever going to do this lazy loading, then basically upgrade it to an eager load.
Yes, and there's I don't think the videos are quite out yet, but Jacob Tyler Walters, the new fellow, gave a great talk at DjangoCon Europe on how fetch modes work. They'll be out very soon. I think they'll be on YouTube, but so do look out for them if you're interested. But how fetch modes work and what the limitations were, and where it's not a magic solution. It's not just let's enable fetch peers in all cases without thinking about it. No. But it's a good change, and when I've spoken to people about what they're excited about in 6.1, most people have pointed to this as their headline feature.
Nice.
So that's good.
And then I guess a little bit. Yeah, go ahead.
Well, I was going to say about the other thing that I'm excited about, that there's an old list of features. The thing with Django releases, every 8 months, there's this big long release page. Go and read it, go and pick your favorite features, but there's always lots in there for everything. But we can now customize the multi-part parser class on the request object. Now, whoever wants to do that, well, it turns out that you can, when you're getting multi-part requests, if you're getting big ones with lots of multi-parts in, swapping out a different multi-parse class could save you maybe 30% on your passing time, which 30% CPU on request for a passing time. That may be a non-negligible gain. So I'm excited about that, but I'm excited because it starts to open the pathway to more customizations on the request. And so, Django's got this implementation, but can we swap out that implementation and compare it and see if we can get some performance gains by being able to turn some of these knobs under the hood?
That's really nice. And having it be customizable is really great. I'm working with this project that I just want to use. I don't want to be an author of it, but It has no real extensibility. So anything I want to do, I have to write little custom bits and change the source code and run it. And I'm like, as soon as there's a new version, how am I going to pay for this? You know what I mean? And so this is really nice.
Yeah, it's again, this is a customizing the multi-part parser class. I don't think that's for the majority of people, but when you need it, it's going to be there, and it's like, okay, actually, there's a big win.
Mm-hmm. Yeah,
so those are my favorites.
Yeah, okay. What's the timeline? It's in beta, you say? So
it's in beta now. So the pre-release is 3 months. So there was the alpha was a month ago. The beta's just now, and then the release candidate will be in a week or so, and then a couple of weeks after that will be the final. So I guess August will be
okay. So it's coming fast. Yeah.
Oh yes. It's very nearly there.
Oh, excellent.
And just a call to action: if you're using Django and you could just install it against your application and run your test suite against the beta, that would be amazing. Because if it passes, then you're all good. You're good to update. If it doesn't pass, then we want to know that. We want to know, what changed.
It's got to be such a challenge to work on a project that's used, not just consumed by people, but like as a programmer, code integrated with this project, right?
Yeah. And there's the whole ecosystem, right? So, I mean, why do people use Django? One of the big reasons they use Django is for these third-party packages that are available, CMSs or image processing packages or, whatever it is that you want to do. Did we break the integrations with them? Well, we hope not. But unless people test and tell us, we don't find out. And when I was fellow for 5 years, and in every release, we would have on release day bug reports saying, "Oh, there's some regression here," when we could have had those a week before and fixed them before the final release.
Yeah. Have you looked lately what the I'll just do it like this. Have you looked at what it says used by on GitHub here? It says, does it say how many projects? I don't. Oh yeah, here we go. This is just the public projects on GitHub, but 2 million?
A couple of million. Yeah, right. Okay, good.
There's so many that are private. There's so many that have nothing to do with GitHub. It's like a very small sampling. That's still crazy.
Jay, a couple of years ago at DjangoCon US, I think maybe 2024, Jacob Kaplan-Moss gave a sort of best estimate about the user base, about 4 million, something like that, as a kind of, 4 million in action Django projects that are in the wild. Okay.
If you count all the internal apps, given that 2 million public repos on GitHub, if you count all the internal private things that people just threw up for like a little internal company app, I bet it's way more than 4 million. I think couldn't prove it, but
yeah. I mean, I'd have to ask Jacob how he came up with the figures, but it was in terms of downloads and looking at this and looking at that.
Exactly. Yeah, probably the BigQuery data PyPI or something like that.
Yeah.
Honestly, I feel like that stuff's kind of broken these days. Like 10 years ago, that was pretty representative, but right now, I think it's kind of a little weird on both ends. I think it's weird because there's so many Docker builds.
Yes.
Right? This project can say, well, it got 100 downloads. Well, that's because like we just built something in CI a bunch of times today. We didn't really intend to download it. That many projects. But also at the same time, there's a bunch of caching layers. Like you might grab a Docker image that has it or build a Docker image and never reload that or use UV caching. Like it's just so opaque, I think.
I mean, a lot of people run little local PyPI caches or pip caches, sorry. So when you do pip install, you fetched it once, but you might have installed it 100 times from that. So what's that meant to be counted as? 1 or 100?
I think it's why it's so hard. I have no idea. So anyway, incredible. And this obviously is, go ahead.
I was going to say, once upon a time, there was an idea to add some kind of telemetry into Django, and obviously that didn't go anywhere because no one wants to go anywhere near that. But it would be still something I would like some idea about how we estimate, because the sort of visible Django community is like 1,000%. So say Jacob's 4 million users isn't too far off. The sort of visible community, the people who subscribe to the newsletter or do the survey or come to Django cons or all these things, they're about 1,000th of that, like 4,000 or 5,000, of people that we can sort of point to and go, I know who you are. I know who you are. Yes, I've heard of you. Yes, I know you on LinkedIn. But that's a fraction of the total user base. It would be lovely if we had some way of just reaching more.
I know. I have a new term for you, Carlton. Dark matter Django.
Yeah, brilliant. I'm having that. Let me write that down.
Dark matter Django.
Yeah,
well, we're going to talk about stuff that is not dark matter. And so you recently did a bunch of work on the documentation and positioning of async in general for Django. Yeah?
Yes. Yeah. So the topic guide, which is here that you've got up on the page, the asynchronous support topic guide, it was first written when we very first added async support to Django back in like Django 3 point something, or I can't remember exactly, but I think it was Python 3.6, right? Was when it is. And async's come an awful long way since then, and it was very negative. It was like, oh, we still haven't finished this, it's still in development, it's still not ready, and the performance implications are terrible unless you do it 100% perfectly. But there was regular blog posts.
Back in Python 3.5, 3.6 days, async and await and this async concept really had kind of a 2 to 3 issue. Like I would, even if I wanted to do it, I got to call this library, which is talking to the internet or to the database, but it's not async. So what's the point?
Yes. Yes, and the costs of the big thing we'll come and talk about a lot is threads. So in Django, we use a lot of a helper from the ASCII-ref library called sync to async, where you take a sync function and you wrap it into a coroutine so that you can await into a coroutine so that you can await that, and it gets run in a thread. And async IO has the 2-thread thing, which is the same, essentially the same option. Sync to async has some ability to track which thread it was called from. So for instance, database connections, they're tied to a thread, and the transaction state is all tied to that thread. So it's important that database queries are run on the same thread as the connection came from. Otherwise, you're going to have problems. And so sync to async adds a few niceties around that, but it's essentially the same as async IO 2-thread. Right, it's go and run this in an executor on a separate thread, and that's great. But that used to cost the orders of milliseconds to bootstrap and set up. And with latest Pythons, it's tens of nanoseconds or tens of microseconds. Sorry, so it's like tens of microseconds when you're doing milliseconds requests. They're not a significant thing, but the documentation was like, no, this is going to slow down your requests, and it's like, hang on, it's really not. And the API is complete, the ORM, the cache framework, authentication, sessions, signals, it's all got async API. So from a user perspective, it really is all there. It doesn't mean there's no work to be done. It doesn't, it's an ongoing project. We keep developing it. We keep fixing new things. We keep adding new things. But this idea that the topic guy presented that somehow the story wasn't finished, well, that's not quite. That wasn't quite right. So we wanted to update that. And we wanted to take some of the warnings about performance and just downgrade them to notes. They're a bit overplayed in this latter day. I
agree. I think this sync to async and back and forth is pretty interesting. And more broadly, one of the things people sort of use as I don't really want to use async, it's kind of bad, is they'll call it like a virus or something. And a lot of times what they mean is like, well, you've got some low level function, it's async. So in order to call that, the thing above it has to be async, which means like the rest of your app, like it just cascades, it's sort of viral in the GPL sense, right?
Right.
But
yes,
you don't have to live with that. You could, go ahead. Sorry.
Well, they call it function coloring problem, right? Is that once you've got a blue function or a red function, all the functions that call it have to be the same color. Right?
Yes, but there's nothing to stop you from going in a synchronous function, just async to sync, boom, and like kind of just stop the propagation there, or create your own async IO event loop and just run that one bit down below. And so you could have a synchronous function, but it maybe calls 5 external endpoints, and you could do all that with async in parallel and just like run that, but cap it right there. I think there's a lot more creativity that we can bring. Just say like, oh, it's a virus. Either it's amazing or we don't want it at all. Yeah.
No, that example you gave of calling 5 external things concurrently, that's one of the easiest ways into async with Django. So you've got your WSGI app, it's deployed, it's got its you've run Gunnicorn, it's got 4 workers running, handling requests, each one in a single thread, nice and separated, so they're not getting in each other's ways. In a separate process, each kind of single threaded, doing its thing. And then you I want to make some API requests. So you can define a single async view, and Django's handlers will run that in a event loop for you, and you can run, say, your 5 HTTP requests, and you can aggregate them together, and you can return a single response, and that can just be done in a fraction of the time of calling one and then the other.
And it's just so clearly a win, right? Do you have to switch to an ASGI and ASCII server mechanism if you're going to use async views in Django?
No, you can run async views under WSGI, right? But you don't. What you don't get is why. This is a good question. So if, say, I'm deployed, say I'm a Django developer, when should I switch to ASCII? When should I switch to async? And the real question is if you want long-lived requests, right? If you want to do, say, something where you do hold open a connection, and you, say, do service center events where every every 5 seconds you get an update for like a stock ticker is a good example, right? You get what was the latest stock price. So, okay, it keeps coming down the wire at you. Well, you don't want to do that on the WSGI model, because each connection is a worker on WSGI. And so you say you got 4 workers, well, that's great, but then, well, hang on, I've got 3 of those are held open by clients. Well, now I've only got 1 serving requests. Well, okay, double your workers, but then you're going to double your users. And if you're using pre-forked workers where each worker lives in a separate process, that's a lot of times that your Django application is loaded into RAM, and say the cache is primed, or the database connections are set up. Yeah, there's a lot of overhead to running multiple processes. Whereas if you can do it with an ASCII worker, you can hold open that connection, and it can just be served on the event loop. You can have many connections just for one.
Right, it's basically tied to an event loop, and then like that can share that thread or that worker as it interlaces across that one event loop, right?
Yeah, exactly. And that's where the exciting thing comes. So if you've got long-lived connections, even if you're just doing polling, you can do polling quite quickly, once a second, and you're not really going to overload your WSGI workers. But if you're holding a connection open, at that point, async and ASCII is really called for.
Yeah, that's cool. So you can kind of have this progressive scale.
Yeah. I mean, and standardly, the people, we have an awful lot of people doing very exciting things, with async. They're either running small projects where a single ASCII worker is enough, and it can handle enough connections, and you don't actually need multiple processes, or they tend to be running at the moment a WSGI base for their app, so standard WSGI base, which is handling most of the work, and then the async endpoints are just running in a single ASCII process as a sort of sidecar. And they do this because something we'll get into is you get what's called you get kind of contention for CPU bound work on the event loop, and we can talk about that in a bit. But I think that's the way people are deploying most successfully for slightly larger applications.
Yeah, that makes sense. And this contention, it is very interesting. It certainly is. I searched for the wrong thing. Hold on. I wanted to actually show. I recently went through this whole process of like, how could I make my server use less memory?
Right.
And I had some of my web apps were running purely synchronous as WSGI, and some of them I had upgraded to like true async, running on ASCII on Granian, right? And I was looking at the server, I'm like, it's using, 9 gigs of RAM for all these products. There's like 27 containers running, but still, It's a lot. I'm like, is there a way that I could just maybe reduce the workers a little bit and make it chill? And so I actually wrote this article about like going through all these different things. But one of the things that I found really helpful was if I could switch to more of the requests being processed by an ASCII server with like truly async calls and down to the database layer and so on, maybe I can use fewer workers. And so I just off like one of my web apps, I cut like 500 megs off because I could just reduce the number of workers because each one was more capable and didn't get bound up. There's still this computational problem you have, but at least you're not doing like, I'm waiting a second for this API endpoint,
Yes.
I thought that was pretty interesting.
No, it is. And it's like it's one reason why people run. So I always run, not always, but I default to running, say, Gunnicorn with multiple workers, multiple processes as workers, because it's separate and you don't get the guild contention issues. But there is a great approach, depending on how much of this CPU work that you're busy doing and how the guild contention comes into play. But if you run with the threaded worker, you've just got one process, and you've got much less memory overhead from running one process than you have from
shared initialization and all that kind of connection pooling, everything.
Yeah, all of it. And so it's never as simple as, this is the way to deploy. This is, how do you deploy your application? Well, how long you got and how many developers are we asking? Because we'll all give different answers for all these really interesting reasons that trade off against each other.
Yeah, it's something I would like to get your thoughts on is I feel like sometimes people say, like, why are we making Python so complicated? Like the magic of Python was that it was simple. And yet there's also another side of that story where people's like, well, I have to switch to Go because
Yes.
I can't do this. And so you got to walk this tight balance of there has to be a simple story, but you don't want there to not be a nice upper bound or high upper bound because you're going to lose maybe your biggest proponents or your biggest users, right?
Yeah.
What do you
Yeah.
think
Yeah.
about that?
No, I think, look, Python. So this fits my brain idea. I think it's something I'm very into, and one of my sort of grimbles about typing is that it becomes not pipe. It fits your brain. I mean, so I was told a story at PyCon Italia. Showed some five typing experts sat around a table trying to work out the correct type hint and these are the absolute gurus, right? And well, no, that's not fit your brain, is it? So part of me is like, on that front, but we have to be performant. You don't want to have to change language just because you need to increase your throughput, just because you're doing a more serious application. That's not good that wouldn't be good for long-term sustainability of
No, it definitely wouldn't. And the fact that you don't have to add typing, you don't have to write async views.
Exactly.
I think that's part of where it's really good because you can grow into that. There is space to grow into.
There is, though, a kind of pressure to the original DEP, which added type hints to Python. It said we don't intend to make type hints compulsory, even by convention. But I think there is very much people coming into the Python landscape. There is a cultural pressure to adopt typing, even if perhaps it's not relevant to you. It's like, oh no, but this is how you do it, and there is a you should, which perhaps doesn't respect the that original promise in the DEP.
Fair, and I think AI throws a whole spanner into it as well. And let's not go too deeply down this because we could spend the next 3 hours on. But if you ask an AI to write Python, a lot of times it'll do typed Python now.
Sure,
without asking.
Yes, and the big issue with AI output is, can you verify it? And so type safety, any type safety that you get from the type checker is going to help the AI verify the output, or help you verify the output.
100%. I think it's a big bonus to AI as well. Whether people care about that or not, that's a different deal. But
indeed.
So, what's left? Where else do people need to focus?
Okay, so performance realities is DB parallelism is your limit, right? So each DB connection is a ordered pipe. It takes a query and it gets a response, and so whether you're doing in threads the way Django does it, or if you're doing it with greenlets the way some other ORMs do it, you're still limited by the size of your connection pool, right? So, and this is, again, and that's whether you're doing it with WSGI or ASCII, the limit always has been the number of database connections you could hold open at a time, basically. So that doesn't really change anything. If you want to scale up, you need to increase the size of your connection pool or handle that more efficiently. That's one thing. Async transactions is something that, because of the way Django's connections are tied to a thread local, we're never going to have async transactions in the sense that you can call await inside an atomic block. Why not? Because that await call may not be on the same thread as the connection, right? So the transaction state is held on the connection, which is on a thread, and if that await call handles in a different thread, you're going to be in big trouble. So it's always going to be the case with Django's choice that you need to take, if you want, it doesn't mean you can't have transactions in async. You just wrap your transaction in a single function, which you then call within a single sync to async, right? So that's always going to be the case. Then there's CPU bound work. Look, if you do work on CPU, you either block the event loop or you throw it to a thread, and then if there's a lot of CPU work going on, you've got GIL contention that we'll talk about momentarily, or you have to throw it out to a separate process. But throwing work out to a separate process is just crazily heavy. You've got to bootstrap that process, you've got to marshal your data, you've got to work out the returns. So async frameworks have tools to throw out to a separate process, but it's not something you want to address lightly. Really, threading was the way you wanted to go, but you are going to hit the GIL, essentially.
Yeah. For people who don't know, if by default, when you use async, you use async and await on a standard event loop, that's single threaded. Even though stuff is happening, it's literally single threaded. And the way that it time slices it or preemptively shares it is anytime you hit an await block, like on a database call or whatever, it's like, okay, that's waiting. So now the same thread can go process something else. But as soon as you're back in regular Python, just jamming on something, well, there's no way to time slice that, right? So everything else is waiting on that computationally.
And you end up with really horrible things like, and I'm going to say it's horrible, I think it really is horrible, right? Is where you've got a loop of CPU heavy work. I don't know, you're rendering and you add in an async IO sleep 0 just to release work. And it's like, why are we doing that? We're doing that because we're running CPU work on the event loop. The event loop wasn't for that. It was for our handling IO, async IO. And we really want to throw CPU bound work to a thread. We just want to, but then we've got Python's GIL. So this is
right, which kind of effectively says, well, you have as many threads as you want, but you still can run one at a time. So
yeah, exactly. So either way, either you do the CPU work on your one thread, which is running the event loop, or you throw it out to different threads and they get GIL contention. And so you end up with essentially one CPU or one thread's worth of clock time, no matter which way you cut it, which is Python's real problem. And it has, it's not actually about switching threads. It's not actually about creating threads. It's not actually about spinning up event loops. Those are relatively quick things. It's about the inability to genuinely run parallel work in multiple threads in Python up until very recently.
Yeah, it's another axis of that. You probably don't need it, but it's a low upper bound that shouldn't be there for people who need to grow into it.
Yes, entirely. And you shouldn't need it. That it can come in at quite moderate scales. It's okay. My Hello World blog application, I'm not going to hit GIL contention. With my 10 requests a minute, it's not a problem if I'm lucky.
That's when it gets popular. Yeah, in the article.
Yeah. I hit hack and use. I've got 10 requests a minute. You're not going to hit. You're not going to hit GIL contention there. But if you're again serious about using Python, a bigger application, yes, you are going to have to do CPU work at some point. Otherwise, the computer's not doing anything, right? The program, if it's going to do something, it's going to have to use the CPU at some point. And so, if you're doing that at scale, the GIL has been an impediment to that. And people are, I'm going to switch to Rust. I'm going to switch to Go. Like, do we have to switch language again? Can we not do that?
Yeah, let's make it so we don't have to. And you don't have to have an insane amount of requests to benefit from this. Kind of like my little example I just showed with the memory thing. Like, if you have to run enough workers that you needed 2 servers, if this free threading thing and the async stuff let you shrink that back down to one more manageable server, it saves you on DevOps. It saves you on complexity.
Saves you on money. Saves you
on money. All these things. So you don't have to be Instagram level of Django requests to benefit from some of these ideas, right?
No, absolutely not. I mean, it turns out, and I've always said for years, with a medium-sized box, you can run a very high traffic server, for realistic terms. But the more you can do on the smaller box, absolutely the better. Absolutely. So 3 threading is the big win. It's the big exciting thing, because Django kind of looked clumsy almost when it said, no, let's just put all the sync work into a thread like that. But actually, as 3 threading becomes more established and it works through the ecosystem, it looks as if Django's bet's going to pay off there. That bet will have aged very well, because we always really wanted to do CPU work in the thread, and
I think it's great. Yeah, I mean, you can have a thread pool. Your threads could each have sort of a hanging around database connection for any time you need it, ready to go. And yeah, you just delegate it out and you actually get parallelism. Yeah.
Yeah, no, and that's the thing. Actual parallelism within Python is really exciting, and that's for everybody. I mean, to go back, why did we update the async topic docs? It's because there are problems that remain with async, but they're not Django specific problems. The same GIL contention problems you have. You type fast API concurrency in, and scaling problems, and you read the same sort of problems, and it's not Django specific. It's not a Django problem there. It's a Python structural problem. Same, database scaling. How do we do it? Well, database pools. Well, same, using Flask, you're going to scale it that way, etc. Right? It's nice that these are general problems that we all share, I think.
Yes, absolutely. Yeah, I mean, and let's see. I think, let's open it. No. There we go. I think it's just so easy these days to try out free-threaded Python too. It used to be, you got to get this weird thing and build it or whatever. But now with UV, it's just literally UV Python install. Like, what do you want? Do you want 3.14.6 T?
Yes.
That's all you say. And in 2 seconds, you've got free-threaded Python to play with and try out.
Yes, and so the thing here, there's still work to be done here, right? Most of it is about the ecosystem, though, not about the architecture. The architecture is kind of already in place, and so if you're at an app level, because people have been running threaded Django for a long time. We're talking about people deploying WSGI with threaded workers. They've been doing that for a long time, but standardly, at the app level, you don't touch things which are multi-thread. So you might have, I don't know, some module level caching. You might have a property at the module level. Well, hang on, is that really thread safe? Do you need to wrap that in a lock? But it's extensions, it's libraries. Are they doing these kind of patterns? And we just need to work through them and run all our test suites against them and make sure that we're compatible with free threading. And then I think we're actually going to unlock an awful lot of performance for everybody. So instead of having to run multiple processes to get parallelism, you'll be able to run it all within one process.
Yeah,
it's really exciting.
I have some really interesting experiments I want to put together with free threading, but the more important work is still out there.
Yeah.
With AI, I'm not ready to go and work on these. I can't do another open source project yet.
Yeah, no, and you must avoid it, because the trouble with I maintain a lot of packages, right? And it's a burden. It's a thing that once you've taken it on, you can't just put down. You might think, it's just a casual thing. You must be very conscious and careful about what you package up and put out there in the world, because you're making a promise to people.
Yeah, Carlton, I'm thinking this is going to be a really good gist, not a repo. You know what I mean?
Yes, right, exactly. Put up a gist, do a blog post, put up a gist, say here it is, but don't put it up as a package, and unless you mean it. If you mean it, then it's a package on PyPI and all the rest. But people can install pip installs directly from GitHub, right? You don't have, or from version control. You don't have to put it on PyPI for people to be able to play with it.
Yeah. Absolutely. So one thing I want to talk to you about, I know you're excited about, is the built-in task framework, because all of this stuff about threading and all of that, parallelism and, event loops, it's fine. But if you could just say, let's just run that, just run that somewhere else. Don't hassle me. Tell us about this.
Okay, so this is a great question, because when we first added async to Django, people were like, this is background tasks. And it's like, no, it's not. It's all about I/O and multiple connections and long-lived requests and things like that. It's nothing to do with having a queue where you want to do some asynchronous tasks. So asynchronous is the word has appeared, but it means other than making people wait. So the standard web scenario, you've got a request and you send a response, and you want that to be as quick as you can. But let's say somebody has a password reset and you want to send them an email so that they can click on the password reset link and they can reset their password. Well, historically, you would have made the request, sent the email, wait for the email to send, which can take almost any amount of time, and then only then do they get the HTTP response. Well, that's a long time to wait. That's a bad user experience, right? So much better is to make the request, say, yes, we've accepted it, put it, we'll talk about where we put it in a moment, and just send the response really saying, look, it's on its way. Give it a few seconds to arrive.
It's already email. It's already async. There's nothing you can do to wait for delivery.
Yeah. So all you can do though is send. So what you do now is you quickly write a task to say the database and with the Django task framework, and you would send that. Then there'd be a worker process running totally separately, which could then send out the email. Say, for instance. Now, people have historically done this with either Celery or RQ or Django Q or then Django Q2, and there are Huey. There's a billion of these task queues out there, and the problem there is that, say, Django itself couldn't rely on them, and neither could any third-party package rely on them. Because, well, I could, but then I'd have to commit to, we're using Django Q2 for this. And all the people who are using Celery or RQ or Huey, they'd be excluded. And so what Django Tasks does is to provide a kind of back-end API that says, look, any package can use this API to enqueue a task and to check results and do the core activities that you need to do around asynchronous tasks. And then just by configuring in the settings what their back end is, can either go for Celery or RQ or, depends, as long as those packages have implemented a Django tasks adapter, you can use those for the back end. And so I think, for instance, Celery hasn't yet done it, but there's an open issue and it'll become. But there are a couple of backends that are available. There's a Redis one. There's a one that uses the ORM to just store in your database, and you can get going with those now. And for me, as a third-party package maintainer, that's fantastic, because now I can add tasks to my third-party package, and users can benefit from those without me having to know anything about which backend they're using.
Yeah. Your pip install or UV install instructions for your package aren't like bracket Celery, bracket whatever. Bracket, and if none of those are there, it's going to throw an exception. So, well, you didn't install any of the queuing options, so now we're busted. You can just delegate. Yeah.
And Celery's wonderful. Like it really is a truly wonderful piece of software, but it's literally overkill for 99% of projects, and it's operationally difficult to keep going. You end up running 3 or 4 different things. You need a monitor, a beat server, the actual worker. It's designed for a level of sophistication that most applications really don't need.
I love that you call out the operational complexity as well, because, like you say, it would be nice to just let people who don't have something complicated use this feature without going, yeah, look, I know you used to, look, that was fun when you could just put it on a platform as a service thing and let it run. Yeah. But now what we're doing is we're setting up a private network, and we got poison messages, and we've got like downtime because like the Celery version had to change, like, oh my gosh, like it's a step jump, right? And just to be able to avoid that is great.
No, it's a serious. If you are taking on Celery, then there is a serious question to ask. If you're an established team, but if you're growing and suddenly it's like, shall we add Celery? It's like, well, hang on, look at your ops capacity and look at your ability to, do you have someone on call for when the workers break down at 2:00 in the morning and page your notifications and all those things? Because it's a world up from self-hosting your bog standard Django app.
Yep. As someone who does a lot of DevOps without a lot of support, I hear that. So, Carlton, I think this could have been like a 3-hour show easily. Yeah. I'm starting to realize, but let's sort of get some advice to kind of wrap things up, which put it on a glide path here for people. Should they write async views today? What do you think about this?
Yes, right. So if I'm writing a small application, like just my local blog application, I want to add a little bit of async sprinkled to it. I might just deploy a single ASCII worker by itself. It's probably big enough. You're not going to hit scaling problems, with low traffic. So, just a single ASCII application. I think as I say, the people who are doing this at a bigger level than that, I think they're running their core application as WSGI and the standard ways, because the scaling patterns there are so established and known, and it's almost trivial by comparison. But then they're running a little sidecar to handle their ASCII. So just have, root Nginx, say, can root by the path, or it can root, by other things. But if it's got a connection header, it can root. But that's a little advanced. Just root by path. Put everything under an A prefix, and then those are your async ones for, I don't know, your long-lived server-sent events requests, and then send everything else back by your WSGI. I mean, just do that. Get the hang of it. You'll find the scaling that scales very well. And then you can say, okay, what if I move this to async? Oh, okay, I start to see some of the complications of async appear. And I think that's the danger I see, is when people dive feet first into async without really understanding that it is an order of magnitude more complicated to correctly handle async code than to just code synchronously. For all these reasons about blocking the event loop, and you get deadlocks, and these are really complex patterns that grow into them rather than jumping headfirst.
Yeah. But Django is ready.
Yes, no, Django's async story is there. The problems that I see come up time and time and time again are problems with Python and Python's async story that we all share, not Django specific problems.
Yeah, or even just asynchronous programming in general.
Yes, asynchronous. Yeah, they are async or GIL problems, not Django specific problems. Absolutely.
I want to just put this out in the universe. If you're looking at your web app and you're like, these are a little bit slow, these requests, so we're going to need to set up some parallelism so that we can handle multiple slow requests at a time. Like, just take an hour and look at your database indexes, please. Like, database indexes are magic. And I'm not saying it's not a benefit to go async or whatever, but if slow is a problem, please just look at the query plans, look and make sure every hot path is using a database index and so on.
Yes, exactly. I mean, and so when you make we always talk about the database, right? But if Django makes a database request, there's a little bit of CPU time to compile the request, and then there's the I/O bit where it's talking to the database, and PsychoPG already releases the GIL in that context, so you're already getting what concurrency or parallelism you would have at that point, and then there's CPU time to sort of marshal the return into, or structure the return data into ORM objects. So those bits are CPU bound, but that core bit is already releasing the GIL. You're already going to get parallelism there. So the chances are you're not going to get much more by jumping to async or adding more workers. It was your database all along that was the thing that was taking the time. These things that we've been talking about CPU contention and all the rest, they come up in only specialized cases. They're kind of advanced topics, if that makes sense. They're often not the problem.
Mm-hmm. Amazing when you need them, but it's not a panacea.
Yeah, and how would I phrase it? We spend so much time thinking about the use cases for the advanced cases that we sometimes forget that the simpler ones are much more simple stories. And should I be writing async views? Well, do it gently. Don't jump into it thinking it's some cure-all. It isn't.
Yeah, but Django's ready. That's cool.
Yeah. No, absolutely. And really, and that's why we made the effort to update the topic doc, because we realized we were giving users bad advice.
Yeah, you're scaring them off.
Yeah, no, we really were. We were like, it's still incomplete, it's not ready. No, it's there. And yes, you will run into problems as you scale up, but that's not Django, that's async.
Yeah, indeed. Final call to action. People considering Django, they maybe are considering async for their existing Django projects or other things like the Django tasks, background tasks, and so on. What do you tell them?
Yeah, I mean, I would get going with Django tasks. You install the database backend for that, which is, or the Redis ones work, perfectly well. If you've already got Redis in your stack and you want a little bit more, but like most people don't need that. Just use the ORM database queue. It's a great storage. That's where you want to throw most of your work. You don't really want to be with Async.io. You can, yes, throw something off to an executor no, but don't do that, because you've got no queue controls, you've got no result. You can't say did it fail and then have logic to retry any of those sorts of things. It's just running on the event loop, and if it crashes, well, what do you do about that? How do you recover from that? There's no elegance to that. So yeah, Django tasks is probably where I would point people first. And then, do I need long-lived requests? Do I want to do things like service-end events or WebSockets? Yeah, that's where. Or streaming responses. Async, great example for.
Yeah. You want to adopt DataStar or one of these frameworks that like really leverages service-end events. Yeah.
Yeah, or HTMX version 4, which is in beta whatever now, which is, I think.
Is that coming with that as well?
Yeah. So they basically were like, right, it's okay. And so I think Carson was like, we're never going to do an HTMX version 3, and he's kept his promise because he's jumped straight from 2 to 4. But it was inspired by some of the things from DataStar and the surrounding projects. It's like, hang on, we can have a go at that as well, I think, said Carson. You'll have to get him on and he can talk you through it.
Yeah, I love Carson. I think what he's doing is great, and I've had him on before. I'm a fan of HTMX, so that's cool. Yeah. Maybe we'll do another round.
Yeah, so when I stepped down as a fellow in 23, I started a new application, been building with HTMX and Alpine since day one, and just absolutely adore it. It combined with template partials, which we added into Django, it's really changed the way I write web applications. It's amazing, all for the better as well.
It's like JavaScript magic fairy dust.
Yeah, it's how it should be.
Sprinkle it on. Yeah, it's exactly. Sprinkle it on there. It doesn't have to be a spa. Yeah. Let's everyone calm down. We can still like do some stuff on templates and so on.
Yeah. But when I learned JavaScript, that was how it was. You detach a few event listeners and just do your little thing, and that was enough, right?
Hashtag dollar document ready. Let's go. A little jQuery back in the day, right? Like that's how it was.
Yeah.
Cool.
Select something.
All right. Something. Exactly. Carlton, thanks for first all the stuff on Django for everybody, and second coming on the show to share it.
No, thanks for the chat. It's been really good. It's really good, lovely, because you pick on the topics, and I'm like, yeah, this is right.
Thanks. See you later.
Thank you, Michael.